today we're going to talk about the intro to FANUC robotics, okay? So if you look over here, this is the FANUC robot lineup. So as you can see here, they have a lot of 6-axis arms. And you'll notice down here in the lower left-hand corner, you'll see some robots that aren't yellow, you know. FANUC is primarily yellow. That's their industrial robotic line. But you'll see the little white robots down there in the bottom. Those are their food-grade robots, okay? So any type of food prep, you're going to use that style robot because they're easier to clean for one, and then also they don't have as many cracks for bacteria to get into. Then right below those are the silver robots. Those are the painting robots. They have a natural finish on them, and they're also anti-static because you don't want any static in the paint booth because we don't want an explosion, okay? So you can see they have a wide variety of 6-axis robots. And then also they have the M-Class, which are their Delta robots. And those have 3 robotic arms with 3 more arms that can be standard or optional on the inside, which control the wrist of that robot. And that's the Delta robot. Now, as you can see down there at the bottom, they run anywhere from about half a kilogram payload all the way up to 1,350 kilograms. So it can do anything from sorting pills up to picking up truck bodies and truck frames. So the robot that we have over here in our cheat cell, so if you look over here, this is the FANUC LR-Mate 200 IC. So this is the spec drawing for that, and every robot, every FANUC robot has a spec drawing. So it'll show you the reach, the payload, the repeatability, okay? So this robot, the 200 IC, has a repeatability of 0.02 millimeters or 0.008 inches. So every time you run that program, it's going to come within 0.02 millimeters each time, okay? The maximum reach of the robot is 704 millimeters or about 28 inches. So from the front to the back all the way up, it's going to be about 28 inches, okay? And this particular robot will lift anywhere from about 5 kilograms up to 11 pounds, depending on which standards you want to go by. And the nice thing is with this is you can set it for different payloads, which will protect the robot, number one, and it'll protect the tooling. So if you're going to run, say, a part that is 5 pounds, you'll set the robot up for 5 pounds. If you want to go for the max, you'll set it at 11 pounds. And what that'll do, that'll help with the jogging rates, and it'll help preserve the motors on the robot so you don't overwork them, okay? So here are the controller and the teach pendant, and some of the things that you're going to do with these controllers are you are going to jog the robot, you're going to check the status, you're going to check for alarms or check what different functions you have on at the time. You'll run programs, edit programs, and you'll also back up the robot. So say you just spent hours and hours and hours programming a new function for the robot, a new program, you get everything perfect, you're going to want to back that up just in case there would ever be some type of power surge or something in the plant, so you have that backed up in the robot. So that's something that you're going to do from either the controller or the teach pendant. Now, this is the R30 IA controller, and this is the one that you're going to have right here on the cert cell. Okay, so you can see we have a main instrument panel there. Now, your main power for the robot is right there on the left. There's your on-off switch. So when you want to come over and actually use the robot, you'll flip that switch on. Next, you'll see the key there. All right, there's 2 different modes to this robot. There's auto mode and there is teach mode, okay? So first of all, when you're first setting up the robot, you're going to want to be in teach mode, okay? Now, in teach mode, the robot will move at fastest 250 millimeters a second, okay? That's the fastest that it'll go. Now, say you program into the robot that you want it to go 2,000 millimeters a second. That's going to be saved in your program, but it will not go that fast until you put it into auto mode, okay? That is a safety feature in there to where if you're in close to the robot, its maximum speed in teach is 250 millimeters a second, all right? That kind of protects you so the robot's not flying around in there to where it can hurt you, okay? So when you set it over to auto, then it will actually run at its actual speed unless we have the DCS turned on. And I'll go over the DCS here in just a little bit. Now, you'll also see the green button there. That's the cycle start. So once you have your program set, you'll turn the teach pendant off, you'll turn it into auto, and then you can hit the cycle start button and it'll run through your program. Now you can also run through your program from the teach pendant, but this is a nice feature for when you're running completely auto. And then you'll also see one of the most important buttons there is the e-stop. So if there's ever any situation where something goes wrong or you need to kill the robot, you'll hit the emergency stop and it'll kill all power to the robot itself. Okay? There's also going to be one of those buttons on the teach pendant itself. All right, so speaking of the teach pendant, some of the key features to this is there is an on-off switch for the top of the teach pendant, okay? So when you're in auto mode, you're going to want to turn it off. When you're doing regular programming, you're going to want to turn it on. Now, just because you turn it off doesn't mean you can't use the teach pendant at all, okay? There's still some functions. You can control speed and some other functions that you can control while it's in auto, so you can make on-the-fly changes. Again, there's an e-stop, so if you ever have any type of problem, what you'll do is you'll just hit that e-stop and it'll kill power to the robot. Now the controller will stay on, but the robot will not move, okay? There are dead man switches. So let me show you this here real quick. So if you take a look at the controller here, if you look on the back, these are the dead man switches, okay? This is a functional switch. It's a 3-position switch, okay? What you have to do is you have to find the middle. There is a completely extended range. There's the middle range where you want to be to actually be able to jog the robot. And then there is another if you squeeze too hard, okay? Basically, this is a functioning switch to make sure that, you know, an operator has control of the robot, all right? So you're not just putting a strap over this thing and pushing them in so you can just do whatever you want with the robot. It's a functioning switch, okay? So it takes a little bit sometimes to get used to it, but everybody will. I mean, it's pretty simple, okay? Next thing you'll see on there is there are motion keys. And why don't you guys come over here real quick, I'll show you a couple things. All right, so we've got our motion keys right here, and I'll get into it a little bit more, but we've got minor axis and major axis, okay? So these are all of your motion keys right here. So to jog the robot, all right, you want to make sure that your dead man switch is in that center position. You're going to hold the shift button, okay? And then while the shift is depressed, you can move any axis that you want here, okay? Now, as you're programming or jogging the robot, you can adjust your speed right here on the motion control. This will go anywhere from a very fine, which is just a click on the servo motor, okay, up to 100%. So it'll run at 100 or 250 millimeters a second, okay? So these are your motion keys right here. You've also got some other things. You've got some executable keys like forward and backwards so you can run through your program. Hold. This right here is the coordinate button. So if you want to look at your different coordinate systems, whether it be world, joint, jog frame, you've got some different coordinate systems you can look through. And then if you hold shift and hit the coordinate, you can look at your different frames. So you can look at your user frames, your tool frames, and your jog frames, okay? So there are a lot of features to this, and a lot more than we'll get into right now, but we'll definitely get into them, and you guys, you'll pick up a lot, okay? All right, so let's go back over here. So speaking of the joints and the major and minor axis, joint 1, 2, and 3 are your major axes, okay? So that's going to be here at the waist. It's going to be this joint right here, joint 2, and joint 3, okay? Those do the major moving of the robot, okay? So when you want to get the robot to a specific spot, those are the 3 axes that you're going to move, okay? Now, your minor axis, you can think of those as your fine-tuning axis, okay? So those are going to be right here on the end effector. And that's going to adjust pitch, yaw, and roll, okay? So you can fine-tune the tool into where you need it to be, okay? And those are the 6 joints of the robot. Now, there are some 4-axis robots, there are some 3-axis robots, okay? It all depends on what style you have, whether it's the Delta robot, whether it's a 6-axis robot, 5-axis robot. There's several different styles, so it all depends on which style you're using to how many joints it's going to have, okay? All right, so then I was telling you about the DCS system, okay? This is the dual check system, and what this does is if you look at our cell over here, you can see that it's got a hard fixture around it, right? It's in an enclosure, okay? So obviously for the robot to try and go out of this enclosure, it's going to damage the robot, okay? So we don't want to just use this as its only feature to keep it contained, okay? So what Fanuc has done is they've got their DCS system, which is going to set an invisible box in here, okay? So you're going to set up a box in this cell that the robot can't get out of. It's going to electronically limit the robot to where it can't leave that cell. So the nice thing about that is it keeps the robot from running into the plexiglass or into the aluminum extrusion, okay? Or it keeps it from running into the worker that's right next to it, okay? So you can set up these fields. They're not limited to a certain size, okay? So you can set them up as you need them. So you can set them up for an entire system if you've got a larger robot, or you can set it up for a confined space like you have here with this cell, okay? So it's just another way to kind of limit the robot and to keep everything safe, okay? Now, another thing that you can do with the DCS system is you can limit the speed, okay? So I told you that, that when you're in auto, it'll run at a maximum speed of whatever you set it at, correct? That is unless you set the DCS, okay? So you can go in and you can set the DCS, even when it's in auto, to a maximum speed. So if you want to make sure that nobody goes in and edits it to, say, 5,000 millimeters a second, okay? You can set it down to, say, 300 millimeters a second, and that's the fastest that robot will go, okay? So the next thing we want to talk about is robot frames, okay? Now, frames are the real meat and potatoes when it comes to moving and jogging the robots and how it's going to react, okay? So here we have a Cartesian coordinate system, okay? It's like an XY graph, all right? When you're dealing in a two-axis Cartesian, okay, you're going to have X and Y. Now, I'll go over it here in a few, but I'll show you how you actually tell where the X and Y of the robot are. But when you first set it up, you have your X and your Y, and you have a point that you want to go to, okay? So we got a point out in space. It is 600 millimeters in the X, 800 millimeters in the Y, okay? So we know that those two are going to work together, and the robot's going to move over to that point, okay? Now you can move there in any type of motion. You can move there in a straight line. You can move there in a joint motion that kind of has a little bit of a curve, okay? But this is a two-axis Cartesian coordinate system, okay? So this is the basis of how the robot moves. Now, with these six-axis units, okay, we're going to add Z to it, all right? So not only do we have a point out in space in X and Y, we're going to add Z so it knows the height, okay? So we're going to have our X of 600, our Y of 800, and our Z is going to be negative 700, okay? So that's just your point out in space, and then you're giving it a depth. So you'll know the height of your workpiece. If you're going to do a vertical move or a horizontal move, you can set all that with your three-axis Cartesian coordinate system. Okay, so when you're dealing with the right-hand rule, all right, this is an easy way to tell how the robot is set up. So if you're looking over here at the robot, this is the back of the robot, okay? So if you look at the picture over there, we've got the right-hand rule, okay? So obviously we have Z, okay? We've got Z. You've got Y, and you've got X, okay? So it's a little bit different. X is going to go it's going to go forward and backwards on the robot, all right? Y is going to go left and right, and of course Z is going to go up and down, okay? Now, that's how it's set up for the world coordinate system, okay? That is the standard system for jogging on the robot, okay? Now, there's another type of mode. It's called joint mode, okay? And joint mode lets you move each axis independently. So all six axes, you can move them independently to where you want, okay? World mode, in this Cartesian coordinate system, it'll move all the axes simultaneously to get where it's supposed to go, okay? So if we look over here, this is the tool frame. So we had the world frame, now we've got the tool frame. So the tool frame is what you're doing is you're going to set that 0, okay? We're going to set that right there on the faceplate. That's where the default tool frame is, okay? Now, in the world coordinate system that we were talking about, it's going to be right here in the center of the J1 and J2 axes. So that's where your 0, 0 point is set off of, okay? Now, with the tool frame, we're going to put it right here on the faceplate. That's the default tool frame, okay? Now, there are a lot of circumstances where we're not going to want that, okay? We're going to want to set that where we're going to want to put it, okay? So what we're going to do then is we are going to move that center point out to where we want it, okay? So if you see over here on this robot, we've got the suction cups, okay? So we're moving our tool center point from the faceplate, we're moving it out and down to the suction cups. So now when we're in a tool frame, the 0 point is going to be right there at the bottom of the suction cups, okay? And that'll be handy depending on what type of task we're trying to get it to do, okay? Because it's got the tool in mind, so it knows that there's a tool on there. So otherwise, you could be jogging it around and you could crash the tool because the robot has no way to know that the tool's there, okay? So when you set up your tool frame, it knows that the tool's there, it knows the dimensions of the tool, so you don't have to worry about it crashing, okay? So as you can see here, here's some different applications. Up there on the top left, we have a spray gun for a painting application. Now the center point is going to be at a set distance of the spray, okay? So there's going to be a center of spray. So you can see that we have that for the spray gun. For our welding robots, we have some welding robots in the other room. The 0 point, the center point, is going to be right there at the tip of the welder, okay? Down here in the bottom left-hand corner, we've got a spot welder. Your 0 point is going to be right in between those two clamp jaws. It's going to come down and weld the spot weld, okay? And then down there in the bottom right-hand corner, we've got a gripper, all right? So it's where the grippers come together and actually hold onto the piece. That's going to be the tool center point, okay? Now, in the tool frame, there's a few different ways that you can set this up, okay? There's a 3-point method, which is going to set the location, okay? So I can say that I want to set it up right over here, so it's going to just set up the location. So right there where that puck is, we're going to say that that's where we want the tool frame to be set up, okay? Then there's a 6-point method, so it's going to set the location and the orientation. So say maybe we skew it a little bit or we want to change it. Say a part comes through, we need to change our process. We can do the 6-point method and we can adjust upon that, okay? So it's not just location, it's location and orientation, okay? Then there's the direct entry method. So if you know the exact dimensions and you don't want to set it, you can input those dimensions or that location, you can input that in, but it's only for 4-axis robots, okay? So really, the best two methods that you can use right now is either the 3-point method or the 6-point method, okay? All right, so then we have a user frame, and user frames are really nice, okay? So depending on where you are, all right, say I'm over here jogging this robot, but I don't like the fact that X goes one way and Y goes the other. I want X to go in the Y direction and I want Y to go in the X direction, okay? I can change that with a user frame, okay? So you can set it up to where it's easy for you to use, okay? Now, I will say if you're in a work environment, you know, if you're in a production environment, you want to check with that or at least let everybody know what user frame you're going to put it in because you won't want the next employee to come in and try to run it and it's completely backwards from what they were using, okay? So, the nice thing about this is you can set it up to the way you want it. So you can make Z go to the left, you can make X go up. You can set it however you want it to go. It's based on your user preference, okay? And then we have a jog frame. And the nice thing about jog frames is we can set it for another orientation. So say I have my puck right here, okay? And I want to pick this up. And I can set a jog frame to where I can come down here right to the corner. It's going to know where that puck is. It's going to know the X coordinate, the Y coordinate, okay? Say I have another sequence or I change my line here and I want to set it up at a 45-degree angle, okay? I can go in and I can set my jog frame. I can set it for that 45-degree angle, set it so I don't have to change my program. I'll just change the jog frame and it's going to know how to pick up this piece based on its new orientation, okay? So that's the nice thing about the jog frame, okay? So at this time, I'll have you guys come over and we'll start writing a program and jogging the robot. Zane, I'll let you take a hold of this, and we'll get started.